Good afternoon, everyone. My name is Mi Yan, data scientist from Intuit. Today, Jolene and I will present the Democratizing AI at Intuit. So, as we know, the life cycle of the model development consists of like data exploration, feature engineering, model building, model deployment, and also model monitoring. So our machine learning platform at Intuit focused on automating all these stages. So our goal is not only to make it easier for data scientists and also machine learning engineer to build and deploy model easily, but also we would like to provide one no-code tools for other internal users at Intuit. In other words, fully automate the whole process. As a part of this automation, we use the auto machine learning provided by H2O DAI to build the model. So yeah, today we will share the journey with the community. So here's the outline. I will describe the motivation of build such an AI service firstly, and then next I will introduce this AI service from different angles, including like features, customer benefits, user cases based on these services, and also Jolene will introduce the AI service enablement and the architecture. And lastly, the future works. First one, as our Intuit CTO mentioned, as the AI-driven expert platform, Intuit is rapidly innovating to solve our customers' most important financial problems. So currently, there are 58 billion machine learning predictions per day at Intuit, and also 330 million AI-driven customer interactions per year at Intuit. So in other words, there's fast growth and high demand of AI at Intuit currently. So that's why we need such AI services. So as I mentioned before, so there's no code and self-serve, and can reduce the time to insight from data by automating various phases of ML ops. And also we leverage auto machine learning provided by H2O DAI, and this service is built on Intuit platform with guardrails. The last part is integrate with Intuit tech ecosystem capability. So what our internal customer can benefit from this service? First one, we can accelerate model deployment by reducing time to build a model from about 6 to 8 weeks before to 2 weeks. And also automatic hyperparameter tuning using machine learning, auto machine learning engine can improve the model performance significantly. The third one is we can detect the potential data leakage and also some potential data shift. And also the one advantage is automate model deployment, which is very important for this service. Last one is integrate model monitoring. Next, I will introduce the 4 use cases based on this user service. So here there are 4 categories here. First one is classification and regression based on some Tableau data. First one is we build one customer churn prediction model and run a gap analysis to guide action or improving customer certifications. Here, first, this service provides the guardrails during the EDA part. Here is the 3 small parts. For example, dropped some constant features and also detect some data leakage. First, we detect some potential data leakage and discuss with users to understand the logic so that we can confirm its data leakage. Third part is the data shift. We detect some data shift between training data and testing data, which helps user better understand and prepare data. And then the automated feature engineering capability created some new features which improve the model performance significantly by about 20%. So in the final model, the model performance in terms of the AUC is about 0.96, which is pretty good. And the feedback from our users said the machine learning model is more accurate when it comes to identify propensity versus the older risk models. So that's we're happy about this result. Next one is natural language processing. So in this project, we identify prospect with a high propensity to purchase service based on some click string data. in this, here we tested two models. One is TF-IDF, the other is BERT. So as expected, the running time of TF-IDF is much shorter than BERT. However, it's kind of surprisingly, the TF-IDF also outperformed BERT. So because when we talk about NLP, usually we said, okay, BERT is always outstanding. However, in this case, TF-IDF is better. The reason is because in this case, the input data is phrases, not sentences, which is BERT good at that. So that's the reason. And also in this project, we provide one capability which is called customer predefined threshold. So before we kick off with this project, we ask the customer to provide one threshold in metrics which they expect. So in this case, we can know if this model, the performance, meets their expectation or not. So here, the expectation from a customer is recall larger than 0.7. At the same time, F1 larger than 0.4. So we can see the initial model, which is in red, is not that good, especially in the recall part. And after some efforts in the final model, we see both of them exceed the threshold. So that is a successful project in this case. Next one is time series forecast. So like at Intuit, you know there's some product like TurboTax, and like in the US, every year the tax date usually around April 15. So in this case, we can expect there's some seasonal yearly pattern in some unit sales or traffic. So our service can provide this kind of prediction so that we can assist with yearly resourcing and forecast. Here's one example. Y-axis is relative values and the x-axis is the date. So we try to predict the 2022 performance in November 2021. So in other words, we just assume today is November 2021, and we try to predict the next year, no matter it's a unit or some traffic or some sales, something like that. So we predict the red curve, which is a prediction, and then we just wait for about 4 months, get the blue curves. So there are two observations here. First one, we can see overall looks pretty good, especially after the February 15th. We can see not only the patterns, the seasonal pattern match pretty well, even the weekly patterns, the small wiggle, also match pretty good. And you may also notice there are two peaks. One is around February, the other is around April 5th, which is the business most interested in. We can see the relative error is only 2%, so that is pretty good. The second observation is we may notice that in the February, there are still big discrepancy between the prediction and the real data. In this case, we need some domain experts help. I just recall the first speak mentioned we need to find a new space for human. So here is why we need a human being here. So yeah, here is a time series forecast use case. Last one is image classification. So if you use the TurboTax, you may just have an impression. TurboTax may ask you to upload your like W2 form, something like that. So in this case, we use this AI service to classify customer uploaded documents automatically to improve user experience. Here is one use case, which is 7-class classification, document classification. In the confusion matrix, we can see in the diagonal is the correct prediction. And I just list the error for each class in the left columns, which is not bad. And overall, the accuracy is 95%, which is pretty good. So this is the last use case I would like to share. So next, I will hand it to Jolene.
Thank you. Hi, everyone. So in this slide, you're seeing a typical model development lifecycle. And with AI services, we can shorten the lifecycle by automating various phases, such as model training, testing and validation, deployment, and monitoring. And I'll show you how we're doing it. So an end user comes to the AI services and navigates to the user interface, and which is represented by the blue box in this case on the left-hand side. They onboard the data set that's already prepared and start a new experiment by clicking on the submit button. And that user action alone sends a request along with relevant model information to the queue, to the job queue. In this case, behind the scene, the queue is fetched and there's a data ingestion workflow that's submitted. This workflow in this case consists of two components. There's data ingestion and data validation. And it's shown in circle 1, color in purple. And in this case, after the workflow completes, the user gets to see the metrics related to the data, and then they get to decide how the metric is looking for their data, and before they decide to go on to training a model. So let's say everything looks good as expected. Now they're ready to hit the submit button to train a model. So again, there's a request that gets sent to the job queue, and behind the scene, this training workflow starts. And the workflow itself consists of several components. The first component is to start an AutoML instance. And in this case, we're leveraging H2O's driverless AI. And once the instance is up and running, the next component will start importing the data, the set of data that were extracted from the previous workflow, split the data by target label, and start the training process. Not only we're leveraging the driverless AI capability to give us the best final version of the model, we're also utilizing the driverless AI's client API to automate the training process. This gives us the flexibility for the automation, and also the entire code base is reusable and scalable. Now, once the training job is done, the following workflows will monitor for that, and the workflows will extract the model artifacts along with a copy of a report, and allow users to review the model performance. And if they want to even submit an ad hoc batch scoring process, they can do so. And once they're satisfied with the model results, they can then decide to deploy the model by hitting the deployment button. Now, another request will get sent to the job queue, and this now it's the deployment workflow. And it'll go through a set of model guardrails before it actually deploys the model to production. Once the model is in production, the users can even reschedule a recurring job for running batch scoring jobs. In this case, we'll assume that it's a offline model. And they can even schedule a recurring job for retraining the model on a regular basis. And this is how we're making the AI no-code self-serve AI solution for our users, and they don't even need to worry about the technical details. And for our future work, we will be expanding the AI services capabilities in the unsupervised learning space. And we'll also be standardizing the data processing for shorten the duration of the project even further. Thank you.